Hello everyone. In this video, we'll be talking about different kinds of fractions like, unlike, proper, improper, and mixed fractions, and equivalent as well. So there are various examples here: 1 whole 1 over 2, 11 over 12, 55 over 60, 1 over 8, 1 whole 2 over 10. So all of these are examples of simple fractions which we learned in kindergarten. Now there are different kind of fractions: proper and improper, mixed, like and unlike, unit and whole, and equivalent fractions. So let's talk about proper and improper fraction. Now, in improper fraction, the numerator is greater than the denominator. For example, 4 over 2. Here, the numerator is greater than the denominator. 9 over 5. Or if the numerator is equivalent to the denominator. Every whole number is improper fraction. Example, minus 24. 24 over, it will give us 24 over 1. That is, the numerator is less than the denominator. The numerator is greater than the denominator. In improper fractions, the denominator is basically less than the numerator. See, in improper fractions, the numerator is greater than the denominator, and in proper fractions, the numerator is less than the denominator, i.e., the denominator is greater than the numerator. Okay, for example, here, this one, and here, this one. Yes, mixed fractions. In mixed fractions, a whole number and a proper fraction are together. For example, 2 minus 2 whole 1 over 4, 16 whole 2 over 5. Mixed fractions and improper fractions are same. We can use any to show the same amount, whether mixed or improper. Conversion: improper fractions to mixed fractions. Divide the numerator by the denominator. The quotient is the leading number. The remainder is the new numerator. For example, if we've got an improper fraction in which the numerator is greater than the denominator, like 9 over 8, we will simply divide 9 with 8. 8 times 1 is 8, 9 less 8 is 1, and therefore it will give us 1 whole 1 over 8. So this is how we convert improper fractions into mixed fractions. Now, how to convert mixed fractions into improper fractions? Now we've got an example over here: 2 whole 3 over 7. What we will do, we will multiply 7 over 2. Okay, 7 times 2 is 14. Now we will add 14 with 3. We multiply it with the number over here, with the whole number, and add the numerator with it. 7 times 2 is 14. 14 plus 3 is 17. So it will be 17 over 7. We multiply the whole number with the denominator and add the numerator to it. The answer is the numerator and the denominator same. Okay, like and unlike fractions. In like fractions, the denominator of the fractions are same. Alright, 1 over 5, 8 over 5, 3 over 5, 4 over 5. All of these have same denominators, therefore they are like fractions. In unlike fractions, the denominators of the fractions are different. 5 over 4, 5 over 1, 5 over 8, 5 over 3. All are very different. Unit fractions and whole fractions. In unit fractions, the numerator of the fraction is 1. In any case, the numerator will be 1. And at whole fractions, the denominator is 1. Remember this. Unit fractions, numerator is 1. Whole fractions, denominator is 1. Converting unlike fractions to like fractions. We will simplify all the fractions. We will find the LCM of all denominators, and we will multiply all the fractions with a special form of 1 to get 84 here. Now these are all like fractions. If we need to convert them, these unlike into like, we will simply take out the LCM of 4, 3 and 7. Over here it's shown 2 times 2 is 4, 3 and 7 will be brought down the same, 2 times 1 is 2, 3 and 7 will be brought down the same. 1 will be carried out, 3 times 1 is 3, 7 will be brought down the same, 7 times 1 is 7, and then we will multiply 2 times 2 times 3 times 7, and we will get 84. And we will check out where in the table of 4 we have 84, and we will multiply the same number with 3. Same goes for 3. You will check out when is 84 there in the table of 3, and then we will write it down. Same goes for 7. Now, equivalent fractions. They are the fractions that may have many different appearances, but they're the same. In the following picture, we have 1 over 2 of the cake, as the cake is divided into two congruent parts, and we have only one of those parts. But if we cut the cake into smaller congruent pieces, we can see that there is 2 over 4, we've got 4 over 8, and 3 over 6. But all of them are equivalent. Equivalent fraction. To know that two or more fractions are equivalent, we must simplify, change to its lowest term. For example, if we got a number as 5 over 10, we will find out a number in which both the numbers come in the same table. Like in the table of 5 times 1 is 5 and 5 times 2 is 10. So it is 1 over 2. A fraction in its lowest terms, or if it's reduced, if we cannot find a whole number other than 1, then we divide into both its numerator and denominator. Now, if we have to check out if 14 and 21 are equal to 30 and 45, we will reduce them. We will divide 14 with 7 and 21 with 7, as both of them are there in the table of 7. We get 2 over 3. Then we divide 30 and 45 with 15, and in the table of 15 both of them are there. We get 2 over 3, and therefore both of them are equivalent. Making equivalent fractions. To make equivalent fractions, we multiply the fraction with a special form of 1. Same numerator and denominator. Okay, like over here. 4 times 5 is 20, 5 times 5 is 25. There are specific operations of fractions: addition, subtraction, division, and multiplication. Additions of fraction. We simplify, we check out for like and unlike fractions. Like fractions are compulsory to add. If they're unlike fractions, then convert them to like fractions. The denominator should not be added, or always change improper fraction to a mixed fraction. Adding fractions with same denominators. If you've got the same denominators, then it's very easy. We will simply add the numerator, and then the denominator will stay the same. As over here, 1 plus 2 is 3, because we've had the same denominator. 6 will be brought down the same. If we simplify 3 with 6, 3 times 1 is 3, 3 times 2 is 6. Adding in fractions with different denominators. Now in the case if we've got different denominators, like over here, we will take out the LCM, and the LCM will be 15. We'll check out when in the table of 3 comes 15. 3 times 5 is 15, therefore 1 will be multiplied with 5. 5 times 3 is 15, therefore 2 will be multiplied by 3. We've got 5 over 15 plus 6 over 15. We simply add 6 and 5, and we will get 11 over 15. Subtracting fractions with same denominator. Same. Subtract the numerator and leave the denominator as in addition. Subtracting fractions with different denominators. We'll take out the LCM as we did in addition, and we'll simply subtract. Multiplying fractions. To multiply fractions, we multiply both the numerator and the denominator separately. We will multiply 2 with 3 and 4 with 2. 2 times 3 is 6, 4 times 2 is 8. We will check in what table both of them come together. Table of 2. 2 times 3 is 6, 2 times 4 is 8. Dividing fractions. So divide fractions, we change the second fraction with its reciprocal. For example, over here, we will multiply 2 with 5 and 4 with 4. 2 times 5 is 10 and 4 times 4 is 16. In the table of 2, both of them come together. 2 times 5 is 10 and 2 times 8 is 16. So this is how we are able to multiply, add, divide, and multiply fractions. Greater than and smaller than. To find out if a fraction is greater or smaller, we change the fractions to like fractions. The fraction with greater numerator is bigger than the other one. For example, over here, 5 times 2 is 10 and 3 times 3 is 9, and the LCM of 5 and 3 is 15.